Hello viewers, welcome back to Sailor Space. So today I'll be taking examination questions for students, COC students and other professional examination. Today's question I'll be taking it from Electrical and Electronics Engineering. It goes this way. In the event of a total failure of the switchboard synchroscope, how could the correct synchronizing moment be identified? In the event of a total failure of the switchboard synchroscope, how could the correct synchronizing moment be identified? Then I'll also be discussing on the second question that says, how could you monitor the correct instant for synchronizing without the aid of a synchroscope or synchronizing lamp? How could you monitor the correct instant for synchronizing without the aid of a synchroscope or a synchronizing lamp? Sometimes this question can be fine-tuned into a more complex question, but it's one and the same. It can go this way. Fire in switchboard has destroyed the synchroscope, paralleling lamps, frequency meter, and voltmeter, etc. How can you put another generator on board with available equipment, either portable or whatever available equipment? Fire in switchboard has destroyed the synchroscope, paralleling lamp, frequency meter, voltmeter, etc. How can you put another generator on the board with available equipment, either portable or whatever available equipment? Watch till the end. Stay tuned as we debate on this answer. I would really love to hear your comments after this session. Let me know your views, how you could have answered this question, and we can share ideas. Thank you. Once again, welcome to Sailor Space, the engineers and navigators of. And if you have not subscribed to this channel yet, please click on the subscribe button, like this video so that a whole lot of people that needs it can also have a reach on it. Share it to friends, to your classmates, to educational groups, etc. You can also tap on the notification bell to get notified when I drop new video. Thank you. So we'll be taking the first question out of the two questions for today on electrical and electronics engineering. In the event of a total failure of the switchboard synchroscope, how could the correct synchronizing moment be identified? In the event of a total failure of the switchboard synchroscope, how could the correct synchronizing moment be identified? So before we answer the question, we'd like to know what a synchroscope does. So a synchroscope is a device on an electrical switchboard that shows the correct moment in which an incoming generator will be paralleled or synchronized with the running generator so that they can both share load and provide adequate supply of power, electricity to the entire system. So the synchroscope helps to monitor the three conditions that are supposed to be met for synchronizing to take place. That's the incoming and the running generator has to have the same voltage, they have to have the same frequency, and they have to be in phase, have to have the same phase sequence. So what do you do when the synchroscope is totally bad? How do you know these three conditions? That's what we are going to talk about today. So if this happens, you can resort to using what we call the synchronizing lamp. The synchronizing lamp is an alternative for us to use when we have total failure. Some people don't really understand what total failure means. They feel it is when you cannot use the synchroscope in the auto mode. No, when your synchroscope fails totally, you cannot use it both in the auto and the manual mode. So you resort to using the synchronizing lamp. It is more like a backup in the event of an emergency, such as the synchroscope getting bad. So if the synchroscope gets bad, the synchronizing job comes into play. So if you look at the diagram, you can see that the synchronizing lamps are connected between three faces of the bus bar and the incoming generator as shown in the diagram. On the bus bar we have the red, the yellow and the blue faces. Same also on the generator, the incoming generator, we have the red, the yellow and the blue faces. So when connecting the synchronizing lamp, when connecting the synchronizing lamps are always connected in such a way that the red phase is connected to the incoming generator's red phase, and the yellow and blue phase are connected, are interchanged in alternate pattern. That is, the yellow is connected to the blue phase while the blue phase is connected to the yellow phase. So how do you use this to know the correct moment for synchronizing? So if you notice also in the diagram, there's an arrow that shows slow, there's an arrow that also shows fast. Now the synchronizing lamps are three. The one that's connected to the red phase is called the main lamp, while the one that is connected to the yellow and the blue phases are the auxiliary lamps. Now, for you to know that the system is in the correct phase with the incoming generator, the red lamp, which is the main lamp, will be dark, while the other two yellow and blue faces lamp will be equally bright. This shows that your system is ready to be synchronized. At the same time, the slow and the fast arrow, if it is running slow, that's in the anti-clockwise direction, it shows that your incoming generator is running very slow. That has to do with speed. Now we are checking the frequency. So if it going in the clockwise direction, in the clockwise direction, that shows it is fast. That means your incoming generator is fast. Either way, if your incoming generator is slow or fast, you trim the governor of your incoming generator to either increase or reduce the speed to make the frequency. But you should note that the frequency of the incoming generator has to be a bit higher than that of the running generator so that it will be able to take load. You should also note that when the light flickers, it shows that the phase sequence are not the same. But when the lights are stable, the red light is dark, and the two other lights are equally bright. That shows that they're in phase and the voltage are the same, and you can close your circuit breaker for synchronization to take place. Okay, the second question we are going to be taking on electrical and electronics engineering today will be: how could you monitor the correct instant for synchronizing without the aid of a synchroscope or synchronizing lamps? How could you monitor the correct instant for synchronizing without the aid of a synchroscope or synchronizing lamps? So I'll also give you another instance where the same question can be paraphrased and asked, but it needs the same answer. Question 2, paraphrase. Fire in the switchboard has destroyed the synchroscope, paralleling lamps, frequency meter, voltmeter, etc. How can you put another generator on the board with the available equipment, either portable or whatever? Question 2, paraphrased. Fire in the switchboard has destroyed the synchroscope, paralleling lamps, frequency meter, voltmeter, etc. How can you put another generator on the board with available equipment, either portable or whatever? So in order to remedy the situation where you have a total failure of your synchroscope, your synchronizing lamp is bad, voltmeter is bad, frequency meter is bad, so it's not like your whole switchboard is in a mess and you need to bring back another generator online to share load. So this is what you will do. According to this diagram shows a picture of an incoming generator, a voltmeter which is connected, then we have a bus bar in an open circuit. So what we should do, but this, before you could do this, you must ensure that you check and you understand the circuit diagram of that particular switchboard before you do this particular method. And you could only do this particular method if you are at sea, or if and you cannot get help and you really need a generator online, not when you can easily fix up the problem. So let's continue. So as it is shown in the diagram, we have to connect a voltmeter across one pole of the open incoming generator circuit breaker. That's when I mean one pole, one phase. In the diagram, the voltmeter is connected across the red phase. So you should always use a voltmeter that has a higher volt reading, because you should be expecting a 500 volt on a 400 and on a 440 volt system. So when you're done with that, connected the voltmeter, and it is also advisable that you use an analog voltmeter. When I mean an analog voltmeter, the type of voltmeter that has a pointer, so that you have good accuracy, because the voltmeter will be acting more like an indicator to show the correct voltage. So after that, if that is in place, you adjust your incoming generator speed. That's after you must have done the connection and check that everything is done well. You adjust the incoming generator speed on using the governor until the voltmeter start to rotate slowly from 0 to maximum. That's the highest reading. So when this happens, you keep monitoring it. So the correct point at which you're supposed to close the circuit breaker with this system is when the voltmeter indicator passes through 0 point position again. That when the voltmeter rotates slowly from 0 to the maximum and comes back through the 0 position, you now close your circuit breaker. Even though this method is not outrightly very safe and is not encouraged to be done, it is only carried out when every other means of synchronizing your generator is not working and you need to bring up your incoming generator to share your load. So this is where we will draw the curtain on today's question on electrical and electronics engineering. Thank you for watching, and also I'll be expecting to see your comments on how you would have handled the situation. I mean the question 2 situation. Okay, so if you have not subscribed, please subscribe, like this video so that they can reach a whole lot of people that needs it. Share it, share it, share it. Comment, comment, comment. See you some other time. Thank you.